After dark, in yards across North America, something moves through the undergrowth that almost nobody ever really looks at twice. It hisses, it bares its teeth, it looks, by any ordinary measure, like exactly the kind of animal you want gone from your property as quickly as possible. And almost every time, the response is the same: reach for a broom, a shovel, a phone, to call animal control. That response is almost entirely wrong. Hidden in the blood of this animal is a protein researchers eventually named LTNF, short for lethal toxin neutralizing factor, and in laboratory testing, it has stopped a lethal dose of rattlesnake venom from killing a mouse completely within hours. This is not folklore. It is a real, isolated compound with a molecular weight of 63 kilodaltons, a patent filed under it, and a paper trail stretching back to the late 1980s. It comes from the same animal curled in the shadows of your yard tonight, deciding whether to run or simply wait you out. And that is only the beginning of what this animal has been quietly doing, unnoticed, for longer than anyone has been paying attention. The story of how we found out starts slowly, the way most real scientific discoveries do. Not with a headline, but with a researcher noticing something odd and refusing to let it go. That researcher was Benny Lips, working through the late 1980s and into the 1990s on the blood chemistry of an animal nobody else in the field found particularly interesting. What she found would take almost 20 years to reach the wider scientific conversation, and even longer to reach the yard where you might be standing right now. Lips isolated a protein from opossum blood serum using high-pressure liquid chromatography and gave it a name that describes exactly what it does: lethal toxin neutralizing factor. It came out to a molecular weight of 63 kilodaltons, and in testing, it did something laboratory antivenoms could not. It prevented death in mice injected with lethal doses of venom from 4 entirely different snake families at once: rattlesnakes and their relatives, cobras and their relatives, vipers and sea snakes. Lips pushed further still and found that just the first 10 to 15 amino acids at the front of the protein carried nearly the same protective power as the whole molecule. That fragment was patented in 1996. And then, for years, almost nothing happened. The discovery sat in the scientific literature, cited by almost no one, waiting. It was picked back up by a research team led by Claire Comives at San Jose State University, who found a way to manufacture a synthetic version of that 11 amino acid fragment cheaply, using engineered Escherichia coli bacteria, instead of relying on drop-by-drop extraction from opossum blood. In mouse studies presented at a meeting of the American Chemical Society, mice given a lethal dose of western diamondback rattlesnake venom alone died within 12 hours. Mice given the same lethal dose alongside the opossum-derived peptide showed no ill effects at all. Researchers at the National Natural Toxins Research Center at Texas A&M University confirmed similar protection against the venom of the Russell's viper, a snake responsible for a large share of snakebite deaths on the other side of the world, in India. A molecule from one unassuming animal sitting quietly in the blood of something most people are afraid of turned out to hold real promise for a global medical problem. But the venom story, remarkable as it is not really the reason this animal deserves a second look from you, personally. That reason is happening every single night, in the grass and the shadows of your own property, and it has almost nothing to do with snake bites. Opossums are opportunistic omnivores, drifting through yards after dark and eating almost anything organic that crosses their path. Slugs and snails disappear into them in large numbers. So do beetles, grubs, crickets, and cockroaches. Rotting fallen fruit, the kind that would otherwise sit and ferment and draw in flies and yellow jackets, gets cleared away. Carrion, too, the small, unlucky animals that die in a yard and would otherwise decompose in place, drawing maggots and disease-carrying insects toward your home rather than away from it. This is not sentiment. It is a documented, opportunistic feeding pattern, and the practical result is a yard with measurably fewer of the pests that actually cause problems for the people living there, all without a single drop of pesticide sprayed into the soil where children and pets will later walk. There is also the matter of safety, because that is usually the real question behind the instinct to reach for a shovel. That hissing, snarling display an opossum puts on is almost entirely bluff. Its jaw strength is weak for its size, and confrontation is the last thing it actually wants. If genuinely cornered, many opossums collapse into a state that looks exactly like death, an involuntary response, not a choice, sometimes lasting minutes, sometimes stretching into hours before they simply get up and continue on their way once the danger has passed. Bites to people are rare, and there is a deeper reason this animal poses so little disease risk to begin with. Opossums run at an unusually low body temperature, typically between 94 and 97 degrees Fahrenheit, well below what most mammals maintain. Rabies is a temperature-sensitive virus, and that cooler internal environment makes the opossum a genuinely poor host for it. Surveillance data from wildlife health agencies consistently ranks opossums among the least likely mammals to test positive for rabies, well behind raccoons, foxes, and bats. If, after all this, you would still rather this particular visitor moved along, there is a right way to encourage that, and a wrong one. The right way is exclusion, not extermination. Remove what draws it in beyond the food you are now happy for it to take. Secure trash lids. Bring pet food in overnight. Rake up fallen fruit. Keep compost closed rather than open. If one has already taken up residence beneath a deck or shed, the fastest humane method is simply to make the space undesirable for a night or two. A bright light or a portable radio left near the entrance, since opossums strongly favor quiet and darkness. Once it has moved out under its own power, seal the opening behind it with hardware cloth, ideally outside the spring and summer breeding season, when a female might still be carrying young in her pouch. The wrong way, trapping and relocating it yourself, or reaching for poison, is not only unnecessary, it is illegal in many states, and largely pointless besides. Opossums are naturally transient, rarely staying in one den site for more than a few days, regardless of what anyone does. Now, for the part of this story that is stranger than almost anyone expects, because it involves science getting something wrong in public, and then having the honesty to say so. In 2009, researchers at the Cary Institute of Ecosystem Studies ran an experiment that would end up defining the opossum's reputation for the next decade. They took 6 kinds of wildlife, several rodent species, a couple of ground nesting birds, and opossums, applied exactly 100 ticks to each animal, and watched what happened next. The results, for the opossums, were extraordinary. While white-footed mice let roughly half of their ticks feed to completion and drop off alive, the opossums groomed themselves so thoroughly that more than 95% of their ticks never survived the encounter. Scientists watched them lick, scratch, and chew ticks straight out of their fur, and later confirmed by examining what the opossums had left behind, that at least some of those ticks had genuinely been swallowed. Because a heavily ticked opossum in peak season might be carrying around 200 ticks at once, the researchers did the math and arrived at a staggering estimate that a single opossum might eliminate somewhere around 5,000 ticks in a single week. The number spread everywhere. It turned an animal most people found repulsive into something close to a folk hero, a walking, hissing shield against Lyme disease, repeated in nature blogs, morning news segments, and backyard conversations for the next 15 years. There was just one problem. Nobody had actually looked inside a wild opossum to check. In 2021, two researchers at Eureka College, Cecilia Hennessy and Caitlin Hild, decided to find out. They collected 32 Virginia opossums from central Illinois and, under a dissecting microscope, searched every one of their stomachs for any trace of a tick, a leg, a mouth part, anything at all. They found nothing, not one tick, not one fragment, in any of the 32 animals. Suspecting this might be an anomaly, they went further, digging through 23 separate published studies on opossum diet stretching back decades. None of them, not one, recorded a single tick either. Their conclusion, laid out plainly in a paper with an almost apologetic title, asking whether opossums were really ecological traps for ticks at all, was that the entire 5,000 tick figure had likely never reflected how opossums actually behave in the wild. Their theory was almost poetic in its simplicity. Trapped in a small laboratory cage with nothing else to occupy them and 100 ticks suddenly crawling through their fur, the captive opossums may have simply groomed obsessively out of boredom, a behavior that a wild opossum, busy foraging across acres of territory every single night, might never have the time or motivation to repeat at anywhere near the same scale. Wildlife organizations that had spent over a decade repeating the 5,000 tick figure, some of the very same institutions that had helped make it famous, issued public corrections. One blog post announcing the reversal was blunt about it, admitting outright that they had gotten it wrong, and that new research had overturned everything they thought they knew. It is a rare and honestly refreshing thing to watch happen in public. An entire community of nature lovers and scientists alike, unwinding a story they wanted very badly to be true, because the evidence no longer supported it. So here is the honest version, the one worth actually telling. This animal will not personally strip your yard of every tick on your property. That specific beloved claim does not survive contact with a dissecting microscope. But everything else uncovered along the way remains true, and if anything, more interesting for having survived the scrutiny. The blood chemistry capable of neutralizing snake venom from 4 unrelated families is real. The unusually low body temperature that makes rabies transmission rare is real. The nightly diet of slugs, rotting fruit, and carrion that keeps a yard genuinely cleaner is real. What changed is not the animal. What changed is our understanding of exactly which of its reputations were earned and which ones were simply too good and too convenient to question. So here's the small, doable thing. The next time you see one moving through your yard after dark, resist the urge to reach for a shovel or the phone. Bring the pet food in for the night, secure the trash lid, and let it finish its rounds undisturbed. If one is denning somewhere on your property, wait until it leaves on its own, then quietly seal the gap behind it. That costs you nothing but a little patience, and it leaves in place an animal that, ticks aside, has spent far longer working in your favor than most people ever noticed. LTNF sat unread in scientific journals for the better part of 2 decades before anyone thought to connect it back to the animal producing it. The tick story took the opposite path, spreading everywhere almost overnight, and it took 15 years and 2 researchers willing to actually look before anyone thought to question it. Both stories, in their own way, are really about the same thing: how long it can take, in either direction, before the truth about something ordinary finally catches up.